this session, I will practice testing without mocks by trying to rewrite the command server program using a test-first approach and testing without mocks. This is the article by James Shore, where he describes a bunch of patterns which you can use to test without mocks. But if we scroll down here to the goals, I think the easy refactoring and readable tests are the two main goals why I am interested in this approach. So easy refactoring means like if you have mocks you like test interactions between objects, but if you need to refactor that interaction, you also have to refactor the tests, and the test will break if you change the interactions. But using this approach, you don't really test the interactions, you test the function provided by the interactions instead. And that's the problem one of the problems I've perceived with mocks, so that's why that's interesting. And readable tests also related to mocks, like tests are much more easy to read when you don't have mocks. And that's also one reason I want to try Python doc test for this, because if the tests are more readable, if the tests are shorter and don't need complex setup, it's more suitable for a doc test, I think. But we'll see. You might have seen me use this one before. So I use it to run tests automatically when I save files. So here I set up a new command server. I'll describe it shortly, but it has a flag which you can use for testing. So if you just run it like this, test, I'll run the test and print OK. And we can run this with the command server like this, and now it will keep run the tests whenever I save the file. So when I save, I'm not sure if it shows up on video, but the command rerun. And the way this works is that I have somewhere in my vimrc command server, yeah. So here, after I've written a file, I execute command server, specifying the file that I changed. So that's how these two processes interact with each other. I started with a docstring and a basic main function. So trying to do this test first, trying to do this outside in, kinda. So I started with like a documentation of how this is supposed to work, like what I just showed you. So a command server runs a command upon startup and repeatedly when told so. And a command client invokes the appropriate command server based on file path. So you can have multiple command servers running, and depending on what file changed, different command servers will get run. So step one is to start the command server in a directory. Here we started running the echo hello in a directory foo, and as you can see, it outputs hello. And then the server registers in that particular directory. So using the file system to know where it is. And then we can start a client in a subdirectory, like in bar, and we can run the invoke. It will get back an OK, and this command server will run again. So here I think you can also specify a path, saying this file changed, and it will use that path to search upwards for a command server instead of the current directory. Another example is if you move to a directory where there is no command server listening anywhere up the hierarchy, you will get no server register or something like that. And also note here, if the server can listen for changes to files in a directory, like using iNotify or something like that, there's no need for this client. The server can do it all by itself. But so yeah, possible future development here. And then the main function here, just checking if there's one test argument passed, we run the doc test. And just to prove that the doc tests are working, we can do something like, and that should fail, saying expected nothing but got 3. So we can solve that by saying 3, like that. This example right here that I wrote like a pseudo documentation, that describes from the very outermost perspective how the command server should work. But these are just examples and they don't actually run. And we're going to do this test first. So what I'm thinking is that basically there are 2 programs, 2 separate processes involved in this command server. And perhaps it's okay to test those 2 in isolation because they're 2 different applications. I don't know. So I will try that approach and see where it leads. So I will start by testing this command server. So let's see how we can do that. First of all, let's introduce a command server application. We can write a doc test for it. And just to make sure that it works, runs the tests. Yeah, so we have tests. Okay, so what's the first thing we want to do? We need to instantiate the command server. And let's assign it to a variable as well. And then we get rid of that error. Cool. And then we can do something like app.run. That doesn't work, so let's add that method. So this is like the main entry point to the server application. And so what's going to happen in this run? So it needs to read the command from the command line, and it needs to execute that command. So let's see, how can we do that? How should we pass? Let's start by passing the command like this. So for example, echo hello. That doesn't work because it doesn't take an argument. Okay, so when we run the app, there should be some kind of output. How can we observe? So like the first test should be like it runs the command upon startup. So this is like starting the application, and then we should observe something being run. So for now, let's just print the command. And that doesn't work, and then we can do self command, and then something like that. This part right here that we passed as an argument, we could do that, but it's if we have a look down here at the main function that runs the test, this is where the arguments come in this sys.argv variable to this process. So one way to think of this is that this is like an infrastructure thing, like asking the system what are the arguments to my function, or to my, what's the argument this process was called with. So one way to think of this is to say something like arguments, and let's call it program arguments. Let's create them like that, and then pass in this as arguments. Now this is arguments. App is okay. So program arguments must be defined first. And now we got program arguments object, but instead we should do, this is really arguments, this is arguments dot get, and this doesn't have a get. Yeah, something like that. But now we haven't achieved that much. We just moved the arguments from a list into a class. But this right here, program arguments, is what James called an infrastructure wrapper. So this is, the get should really be sys.argv, something like that. And yeah, as you can see, now we're not getting echo hello, but we get the actual arguments that this program was called with. So what we want to do now is to have this be nullable. So okay, so let's write test for this. So if we do program arguments create null with echo hello dot get, we should get echo hello. Okay, so static method. Oops, let's use the Python convention here. Okay, so this test still failed. What else failed? Oh, this fails as well. Why? Yeah, we'll see in a second. So let's see. So program arguments should really not take the arguments. It should take the sys module, and then access it like this. should default to the sys module of Python. And the infrastructure, the nullable version, which we describe here, should pass in a sys null with arguments, and sys null or really it should just say sys.argv is none, like the first argument of skip plus the arguments like that. Sys is not defined. Okay, so let's move this one from here all the way up here. List object has no argv. Oh yeah. Or wait. Argv. Line 69. This fails. Why does that fail? List object has no attribute argv. And what test is it? App run. List object has no argv. So sys is a list object. Yeah. So yeah. Here we should create the null version instead. Create null. And now it's working again. So yeah, program arguments is a infrastructure wrapper, and it's also nullable infrastructure where we can. So this is program arguments is a infrastructure wrapper for the Python sys module, kind of, or small part of the sys module. So by default, the sys module is used, and we can create a null version by passing in a different sys module, which mimics the sys module in ways we want. So also, if we create the program arguments as this, we should get the arguments to this one. So not sure if this is a reliable test, but yeah, sure. So now we have tested the nullable version and we have tested the real version. And in most cases, testing the real version is much more complicated than this. In Python, this is just accessing global state somewhere. So it doesn't involve talking to a server or accessing the file system or anything like that. So this test is probably many times much more difficult to do. I would like to say that it can be instantiated without arguments. So this is basically saying We don't care about the results, and we can do instantiate the command server app. This is not possible today because it needs the arguments, and I want to default this one to none. And really, I'm not sure. So this is one question I have. So this is one thing that I think the example that James Shore is not tested. So like this case is not tested at all. It's only tested when you actually run the thing. So yeah, what we want to do here is say arguments or program arguments like that, so that we run with the real arguments. So, but if we start doing something, if you do like this, it will run the application for real. And we don't really want to do that, because then we'll start servers and access file systems and stuff like that. And the point with this testing without mock strategy is that a large part of the application you test without interacting with the outside world, and you only test the outside world integration in these kinds of tests, like very specific infrastructure tests. So maybe we'll see later on how this can be more complicated, but yeah. So I'm not really sure how to test this part, and we can't do run, but we can make sure that it instantiates. But if we just provide a default of none, this is not going to work anyway when we actually run it. So yeah, I don't know. The way James did it in his example was that he defaulted it to write something like this. This will not work in this particular case because program arguments is defined below, so we need to go define it before. We could do that. But even if we do that, we're not testing that we're instantiating the correct thing. We can write whatever and all the tests will pass. So yeah, not really sure how to handle that. But yeah, let's do this for now. If we do this, we are at least testing that the command server app can be instantiated, so we're actually instantiating program arguments. We have the application. It can, when it's run, it reads the command to run from the environment, and it prints that command. But we don't really want it to print that command. We want it to execute that command. So how can we do that? One way to do that is so this is also talking to the external system. And when I experimented with this before, I came up with something called the process factory. So this is another infrastructure wrapper around Python's subprocess module. So process factory is process factory create null, something like that. That doesn't exist, so let's create it real quick, just so that the example above works. So process factory, let's remove all the tests, and process factory. Okay, I expected that to work. Why didn't app is not defined? Because yeah, command server app takes 2 positional arguments. Okay, so command server app now needs to take the process factory as well. So let's do the same for that one. Process factory or process factory, like that. Okay, so now we're back. And now up here in the example, we want to say something like app run should not run anything. But we can do something like ask the process factory for the get last spawned or something. And we will get back some kind of process where this command is in. So process factory does not have get last spawn, so let's flesh out, let's ignore these for now, and let's flesh out the process factory. So let's test the null version first. So I have process factory, create null, get last spawn should return some kind of process. And in this case, none, perhaps. I don't know. Last spawn is none in the beginning. Yeah. Get last spawn. We can just do it like that. Oh, and none doesn't show up in doc test, so yeah, like that. Factory, let's extract this one and do factory, like that. And then if we do factory dot spawn echo hello, last spawn should be a process with echo hello. Alright, so let's see if we can do this. Def spawn command self last spawn, create the process with command, something like that. And here we can return self.last spawn. Has not initialize it. And okay, last spawned got nothing, and I suspect that's because process is not defined. Sure. So let's define this wrapper for process. Right now it takes a command, and we need to define a wrapper for output in doc test. Process, and this is self.command. There we go. Okay, so now we have tested the null version. What we haven't tested in this process factory is that it actually spawns a process. So here is a test null version, and what we have to do later is test real version. So this will begin by saying factory, process factory, like that, and then doing something real with this. but we'll leave this for now. We can go back here and see why is this not working. Process echo hello. Got nothing. Process factory. Get last spawn. Okay, so we've tested get last spawn and we know that that one works. So why doesn't it work here? Oh yeah, that's because we haven't implemented actually running process. So when we run the command server application, we should not return arguments. Instead we should do say like self.processFactory.spawn self.arguments.get, and there we go. So now we are getting somewhere. So the test here, it runs the command upon startup. So we start the application, and we verify that the process, the last spawn process, is this echo hello that we simulated the program arguments to be. And assuming that we implement write test for program arguments and process factory, this should actually run, this should work in the real world. It should run and the process specified. Yeah, so program arguments is already implemented, right? We have, this is the test null version, and this is the test real version. So let's see if we can do the same for process factory. So process factory needs to take yeah, so it should use the subprocess module of Python to execute this process. So how can we assert when we do here factory dot spawn echo hello. So we can, first of all, this should work, right? It does. But what should we? Yeah, this returns a process. This returns a process, and can we say something about this process? Yeah, one thing we can say is like process. We can implement something like get PID. Maybe. Yeah, something that shows that the real process was spawned. It's not a complete test, but yeah, maybe this is good enough. So what should this look like? Yeah. So first of all, the process should not get a command. It should get like a subprocess thing. So here we want to do subprocess.popen command and pass that to the process. So now process is not defined, so subprocess is not defined. Okay, so let's import that. Non-type object has no attribute get PID. Process, so spawn is not actually returning anything. So spawn should also return self.lastSpawn. Process object has no attribute get PID. Sure, it doesn't. pass. Okay. So yeah, we're getting hello messages, and yeah, the process is written like this. Yeah, so perhaps we also need to pass, yeah, to the process we need to pass, sure, we can pass the command and then we can pass the open object. Let's pass that one as well so that output is correct. Process, command, and open. Factory spawn, echo hello, expected nothing. Okay, so test null version, we can do something like p, and then we can say also something like we can add a test saying that p should be the same, something like that. Okay, so now apparently this thing is executing 3 times. We're getting some output here, not really sure why. Is it this one that is executed 3 times? So one. No, this is just executed once. So the problem is with the null version, it's also using the sub process, the real sub process module, and yeah, so here we do, not sure, 2. Okay. So the null version should not use. We can test that as well. So null version does not spawn a real process. But anyway, this should not work. Get PID, we should get something here, like a number, but we are getting nothing. So is none should be false. We should get a number, or we can even say is instance integer. Yes, the PID should be an integer. True. Okay, so get PID, we can do something like self.popen.pid, I think. No? Okay. So let's add this back so we can see what it is. Okay, so this one is, so it's, we're getting nothing back. Let's okay, yeah, there. Okay, so we're getting back in. Yeah, so we need to recharge this one. And yeah, now we're getting a PID. So now we can add this test back saying, yeah, got a PID. And now we should really add a test saying that the null version should get no PID. And how do we do that? Basically saying that p get PID is none, true, and it's not in those cases. So in the null version, let's see, process factory, we need to supply a null sub process. Need to create that as well. Null sub process. And it takes the sub process and we default it to the Python subprocess module. And this should be self.subprocess, and now I suspect null subprocess has no attribute open. So now we're simulating the subprocess module here. Just to pass, and here we need to return a null open, and the null open has a PID of none. There we go. And we can also see that the other two hellos disappeared because they use the null version now. And the only time we actually spawn a process is when we test the real version of the process factor. This is the only test that accesses the external system. And one thing that would be nice, perhaps, I don't know if it's necessary, is to actually assert that this hello comes out, so that we test that we actually ran the hello program. We actually ran the program that we specify here. Now we're just saying, hey, this thing that we get back, it must have a PID, which is an integer. But we can see in the console here that hello is output, so I think this is good enough for now. And I think now, not entirely sure, that this might actually work now if we hook it up here. This part right here is just as so the command server can test itself if it has a test argument. If it doesn't, then we can instantiate the command server and run it like that. And it should run the command that we specify on the command line. So let's see if this actually works. So Python command server echo hello, and it does, and then it exits. Yeah. This is like the seed of the application that we can start to build out. So now the next thing here, it runs the command of startup. Next, like it runs command when invoked somehow. And yeah, maybe we want to play a sound when the command succeeds and play another sound if it fails, or like draw a red or green bar or something like that, which should also be part of the command server app. One critique of this approach is that all the like null process, null open are it's implementation code that you test, but it's only used for test purposes. But I don't know if I have a big problem with that. But yeah, I want to continue to explore this style, and I don't know, perhaps I can finish this whole command server program using this approach and learn more about it. Thanks James Shore for inspiring me to try this. Looking good so far. And also doc tests, quite nice. If you want to have a look at this code in more depth and study it at your own pace, I will leave a link to the project at GitHub, and you can also follow along on any progress I make there. So I think that's it for this session. I'll see you in 1 week.